Ocean acidification is one of the major environmental challenges affecting marine ecosystem worldwide. It occurs when the ocean absorbs excess carbon dioxide from the atmosphere, causing a series of chemical reactions that lower seawater pH and reduce the availability of carbonate ion needed by many marine organisms. Coral reefs are among the most diverse marine ecosystems, supporting approximately 25% of all marine species. Ocean acidification reduces the ability of corals to build and maintain their calcium carbonate skeleton, resulting in slower reef growth and weaker reef structure. This problem has become increasingly evident in many parts of the world, threatening not only marine biodiversity but also millions of people who depend on coral reef ecosystem. One of the examples is the Great Barrier Reef in Australia, where coral cover has declined significantly over the past few decades because of multiple environmental stressors, including ocean acidification and climate change.
Plankton may seem small, but they are the head of the ocean as primary producers. As we know, plankton is divided into two, which are phytoplankton and also zooplankton. The problem is the increase in carbon dioxide causes the ocean to become more acidic. The increasing acidity of the ocean reduces carbonate ions, causing plankton such as coccolithophores, pteropods, and foraminifera to fail to build shells. In fact, their shells dissolve and become brittle. So, what the impact? The impact is the marine food chain will experience a bottom-up crash. When plankton declines, commercial species such as salmon and tuna lose food source, which ultimately cripples the fishing economy and human food security. In conclusion, if the foundation of this food chain collapses, the entire marine ecosystem and human economy will also collapse.
To overcome the impacts of ocean acidification, several mitigation measures can be implemented. Firstly, coral reefs should be protected and restored because they are highly vulnerable to changes in ocean chemistry. This can be achieved by establishing marine protected areas to reduce harmful human activities, carry out coral reef restoration programs, and reducing pollution and overfishing that place additional stress on coral ecosystem. Secondly, it is important to protect our plankton and marine food webs, such as plankton form the foundation of the marine ecosystem. One of the most effective approaches is reducing carbon emissions because excess carbon dioxide is the main driver of ocean acidification. In addition, regular monitoring of ocean chemistry can help detect changes in pH levels and identify areas at risk. Protecting marine biodiversity is also essential because healthy and diverse ecosystems are generally more resilient to environmental changes. Overall, these measures can help minimize the impacts of ocean acidification and support the long-term sustainability of marine ecosystem.